All right, we're beginning section 11.1, Basic Concepts for Probability. So first let's start with the definition. Probability is the likelihood that a given result will occur. For examples, in the winter we can talk about a chance of snow. What's the likelihood that it will snow? We can also talk about the chance of flu. During flu season, what is the likelihood someone will get the flu? We say that the observation of a random phenomenon is an experiment. The results of the experiment are the outcomes. How it will play out. What are the possibilities? The set of all possible outcomes is the sample space. So the sample space can be thought of as a set. Remember, a set is just a list of objects. The objects for us would be all the possible answers from running an experiment. Any subset of the sample space is called an event. So if we revisit a Venn diagram to kind of put this down in visual terms, our Venn diagram, we're used to calling U the universal set. Remember, that includes everything. For us, we're now in chapter 11 going to call it S for the sample space. So S references the sample space. This includes all possible outcomes. And then inside we could draw a circle and say inside that circle is a particular event. So let's look at an example. Let's say the experiment is to roll a fair die. Well, our sample space would be the outcomes that we could see. So we could see 1, 2, 3, 4, 5, 6. A particular event, E, could be all outcomes less than 5. Note, P of E is notation for the probability of an event. Now, we're going to look at two ways that we can talk about probability. One way is theoretical probability. And theoretical probability will use all of those skills we learned from chapter 10. Another way to find probability is called empirical probability. Empirical probability is just physically running the experiment over and over again and looking at results. So let's break these down further. Let's first talk about theoretical probability and define how probability is found using theoretical probability. So if all outcomes in a sample space S are equally likely and E is an event within the sample space, then the theoretical probability of event E is given by the following. We're going to produce a fraction. The top of the fraction will be the number of ways E can occur, E being the event. That's the numerator. Now the denominator is all possible outcomes from the sample space. So if we use some notation from chapter 2 when we talked about set theory, it would be the size of E over the size of S. How many ways can E occur over how many total ways happen in the sample space? So let's look at an example. If a single fair coin is tossed, what is the probability of getting tails? Well, our sample space is we could either see heads or tails. So if we're interested in the probability of getting tails, well, how many times do I see T? I see T once over how many total possibilities are in my sample space? 2. So the theoretical probability of seeing tails is 1/2. Right? The second way to talk about probability is empirical probability. So this is actually physically running the experiment. So it's still found by a fraction. The top is the number of times E occurs in the experiment. Over the total number of trials in the experiment. All right, so let's look at an example. If a single fair coin is tossed 10 times, what is the probability of getting tails? Well, let's say that Joe tosses it 10 times and he gets 4 tails. Let's say that Mary tosses the coin 10 times and she gets 6 tails. And let's say that Mark tosses the coin 10 times and get 3 tails. So for any one of these, the probability for Joe would be 4/10. This would be 6/10, and this would be 3/10. That's because it's how many times we saw tails over 10 tosses. So what's important here is the law of large numbers. The law of large numbers states that as you repeat the experiment more and more times, the empirical probability will approach the theoretical probability. Because remember, the theoretical probability of seeing tails is actually 1/2. And none of these 4/10, 6/10, or 3/10, none of them are 1/2. Thus, for the above example, if we would toss the coin, let's say 100 times, the probability of tails should go from, let's just take this one. So this one is 3/10, because we see 3 tails out of 10 tosses. We would go from 0.3 to closer to 0.5. Now the next statement is one of the most important statements that we need to know for probability. So here's the truth. The probability of any particular event happening has to be a decimal. It has to be a number, 0. It can be any number between 0 and 1, because P of E equaling 0 would suggest that the event cannot occur. It's not possible. And P of E equaling 1 would say that the event must occur or would occur all the time. any decimal between 0 and 1 is the likelihood that the event will occur. So this means that answers to probability questions should always be between 0 and 1. So let's look at some examples. 1. Give the probability that the spinner shown would land on keychain, no prize, and baseball hat. So the probability of keychain is a fraction. The fraction is how many times we see keychain over how many total spots the spinner could land on. So I see keychain twice out of 6 choices on my spinner. So 2 6, which I'm going to reduce to 1/3. So my probability of seeing or landing on a keychain is 1/3. Probability of no prize. Well, the denominator is still 6 because it's the same spinner. No prize is shown 3 times, so my probability is 3/6 or 1/2. Probability of baseball hat is still 6, but how many times do I see baseball hat? I see it once, and that fraction is already reduced. 2. Mitch has a collection of 40 pairs of tennis shoes. His collection includes 12 Adidas Ultra Boost, 15 Nike Huarache, 6 Vans, and 7 pairs of Jordans. If he randomly selects one pair of shoes, what is the probability the pair of shoes is a Nike Huarache? So the probability that we choose a Huarache is a fraction. The top is how many Huaraches he has in his collection, 15. The bottom is the full sample space, or how many total pair of shoes he has, 40. Small fractions like 15/40 must be reduced, so 3/8 would be the probability of selecting Huaraches. So we've kind of started discussing the idea of finding probabilities, and now we're going to pause and talk about what goes along with probabilities. What goes along with probabilities are the odds. So let's define that. Odds compare the number of favorable outcomes to the number of unfavorable outcomes. So example, odds I'll win the lottery. Two, odds you'll graduate. So let's talk about how we find odds. To find the odds, if all outcomes in a sample space are equally likely, we're going to say A of them are favorable to an event E, and the remaining B outcomes are unfavorable. So here are how we state odds. In favor of E are A to B. Against E, we just simply spin that around and we write B to A. So let's look at an example here. If a single fair die is rolled, what are the odds in favor of rolling a number less than 5? So first, let's look at our sample space. Our sample space would be 1 through 6. A is the favorable answers, the answers that would satisfy a number less than 5. So if I look at my sample space, there are 4 numbers that are less than 5. B are the unfavorable outcomes, or the numbers that are not less than 5. So 5 is not less than itself, and 6 is not less than 5, so 2. If I want to write odds in favor, it tells me that I write A to B. So I'm going to write 4 to 2. Now the only issue with that answer is we need to reduce odds like we reduce fractions. So both of these numbers are divisible by 2, so I'm going to reduce my answer down to 2 to 1. So this would be my odds in favor. If I want to do odds against, I simply talk about B to A. So that would be 2 to 4, and then I do the same thing. I reduce. So I would get 1 to 2. Or we simply could have taken this answer and turned it around. So there's something important to be said here. You should be able to convert from probability to odds and vice versa. Here's what might help you. If the odds are A compared to B, meaning all the ways we want it to happen to all the ways it won't happen that way, then the total number of possibilities for the denominator in probability, or this is the full size of the sample space, is A plus B. So let's run through some exercises that are talking about odds. So let's say the odds are 3 to 2 in favor of a particular event. What is the probability of event E? So this is so if we want the probability of event E, the best way to consider that is we want to know A over A plus B, because A is all the ways it will happen, and up here it says A plus B is always our full sample space. Well, if these are odds in favor, A is listed first and B is listed second. So we would have 3/5. So our answer would be 3/5. Now let's say the odds are 9 to 2 against event E. What is the probability of event E? Well, we still find it this same way. We always find the probability of an event by looking at what we want over every possible way it plays out. But now we need to be careful. These numbers here are written in the form of being against. So if we scroll back up, against is written B to A. So this is my B and this is my A. So my A is 2 and my A plus B is 11. So my probability would be 2/11. Now those two examples were given odds, find probabilities. Remember, we're supposed to be able to go forwards and backwards. So now let's say the probability is 4/7. So we know the probability of an event is 4/7. What are the odds in favor of event E? So remember what this means. This means A, and this is A plus B. So if we want odds in favor, we want to write A to B. Well, A is shown exactly in the top, 4. So if this is 4, this A is also 4. 4 plus what gets us 7? So we're going to say 3. So our odds in favor are 4 to 3. A way to check from going from probability to odds is these numbers in our answer should always add to our denominator. Last one, the probability of a particular event is 0.36. So the probability of E is 0.36. And it wants us to find odds in favor. Well, my suggestion here is to think about this as a fraction. So 36 over 100, and then we're going to reduce it. This fraction is reducible by 4, So we're going to get 9 over 25. Odds in favor want A compared to B. And remember, this is always A over A plus B. So A is 9. B is what do we add to 9 to get to 25? So 16. Or remember, these two numbers when added should always make the denominator.